Hello everyone, it's your favorite chemist again, Adrenaline, the Bazooka Prophet. And today I'm going to be teaching you or taking you on a swift drive to the to a new area of chemistry, which is so-called organic chemistry. A lot of students have complained so much that that adrenaline, when are you going to do video on organic chemistry for undergraduates and also for O-level students? And today, I'm going to be taking my time to give you a series of tutorial on the introduction to organic chemistry. Because the truth is, if the foundation of a child organic chemistry is bad, it's going to affect so many aspects because organic chemistry is an evolving concept. So I'm going to start first of all by talking about the definition of organic chemistry, and also we'll talk about the a brief history of organic chemistry, and lastly on this first episode on the uniqueness of carbon, which is a major element in the definition of the concept of organic chemistry. Are you there? So let us go. Now, organic chemistry is a branch of chemistry that deals with the study of carbon, which is an element of carbon and its compound. Take note, the study of carbon and its compound. Now, we should understand that in the concept or in the definition of organic chemistry, not all areas of carbon are talked about. That is why in the definition of organic chemistry, we exclude or we do not involve the following. Talking about the oxides of carbon, cyanides, carbonates, bicarbonates, even carbates or carbides. Now, this here that you can see are not part of the study of carbon in the field of organic chemistry. Why? Because they are found or they are talked about in inorganic chemistry. Take note. So I can go again to tell you that organic chemistry is the study of carbon and its compound, excluding the following: the oxides of carbon, which include carbon 4 oxide and carbon 2 oxide, cyanide, like hydrogen cyanide, potassium cyanide, etc., carbonates, bicarbonates, even carbides. All these are not studied because they are inorganic. Is that clear now? Again, we can also define organic chemistry as a branch of chemistry that deals with the study of hydrocarbons. 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 Hydrocarbons and its derivatives. Now, before I go further, we should understand that hydrocarbons are defined as organic compounds that contain just two elements only, which are hydrogen and carbon, meaning the combination of hydrogen and carbon is what gives us hydrocarbon, and hydrocarbons are organic compounds. Take note, hydrocarbons cannot be defined as the study of hydrogen and carbon. No, Rather, it is an organic compound that deals with hydrogen and carbons only. So we'll move further. Now, when we go further, we'll talk about a brief history of organic chemistry. So let us please take note of the following here. Now, as we move further, we will then talk about a brief history of organic compounds or organic chemistry. Now, let's go. Now, basically, we have two main classes of chemical compounds, and they are inorganic and organic. Now, these two chemical compounds were defined as, or were classified based on the origin in which substances are derived from. For example, in the case of inorganic, compounds that are derived from minerals are termed inorganic, from mineral origins, while the ones that are derived from vegetables, which is from plants, and also from animal origin, they are classed or termed organic. That was the old concept of the definition of inorganic compounds and organic compound. Please do not get it twisted. For example, in the case of inorganic compounds, when we have table salts, when we have carbon dioxide, when we have marble, all these were classed as inorganic because they are derived from mineral origin. But in the case of organic, for example, alcohol, whose sources is from wine. We can also have tartaric acid, whose source is from grape. We can also have citric acid, whose source is from lemon. We can also have acetic acid, whose source is from vinegar. Now, all these were termed what? Organic, because their sources are either from plants or animal origin. Please, I'm taking it very slow such that a student in secondary school from SS1 or SS2 or SS3 and even undergraduate who is a slow learner could get the basic concept. Because with this concept, you can do as occasion serves you. So let us continue in the history too. Now, all these were hold on to that it was termed that for a thing to be organic, it must come from a living matter. Why? Because it was believed that there is a vital force in a living matter that produces living what? Substances. That was the idea. And a theory to that regard that hold on for a century, which is called the vital force, called the vital force theory or the vital theory. Please take note of all these major key points. Vital theory. And one of the pioneers of such theory is called, or his name is called John's Jacob Berzelius. Let me spell for you. John's Jacob Berzelius. Now, this idea of only living thing can produce this, or only living thing can produce living substances. We have hold on for years until in the year 1828, when a German chemist named Friedrich Wöhler, spell Friedrich Wöhler, is a German chemist, and also he was working in the lab, or he was a student under the famous great scientist John Jacob Berzelius. Now, in the lab of John Jacob Berzelius, Friedrich Wöhler was able to break that concept of only living can produce living substances. And what was the idea? Friedrich Wöhler produced, or was able to eat, an inorganic compound to produce an organic compound. And inorganic compound was ammonium cyanide. And the organic compound was what? Was urea. And when the urea was tested, and urea was also isolated from human urine, it was discovered that both of them had the same the same smell and the same composition in all aspects. And look at how it was done. This is ammonium cyanide. When Friedrich Wöhler heated it, an inorganic compound, urea, was produced. This is the chemical structure for urea. Remember that urea is a waste product in man, and urea is, like, when urea mixes with water, forms urine. So we move. Now, that idea of organic to organic, although it was still there, it took a long time for that concept of living to be disproved, until so many years when it was now confirmed that, okay, this idea of only organic to organic will no longer hold anymore, because more compounds were being produced. So the emphasis of the definition of organic chemistry was now shifted from origin sources to composition, and it was discovered that carbon is found in all organic matter, or organic substances. So that was when the concept and idea of the definition of organic chemistry came, as the study as organic chemistry is now defined as the study of carbon and its compound, excluding the oxides, the cyanides, because these were found in inorganic. I hope you get that little bit of history and take note of the major points. Very, very simple, very, very important. Likewise, take note. And because of what Friedrich Wöhler did, he became known or regarded as the father of organic chemistry. And we'll move straightway to the uniqueness of carbon. Why is carbon so important that it is most talked about in the field of organic chemistry? Number one is that carbon is found in many organic compounds. Apart from carbon being found in many numerous organic compounds, it's also found in inorganic compounds. So carbon is well known in organic compound, and every day many organic compounds are synthesized. Many organic compounds are extracted from different sources. That is number one. Very, very important. And number two is carbon has the ability to combine with itself to form longer chain or longer carbon structure. And we call that in chemistry as catenation. Please take note, catenation. That catenation is the ability of carbon to combine with itself to form longer chain. For example, carbon combining with itself to form longer chains. And the chains that carbon compounds can form can either be straight like this, look at it, can either be straight or can be branched, as you can see like this, or it can also be closed, as you can see like this. So carbon has the ability to form or to catenate. And I've told you that catenation is the ability of carbon to combine with itself to form longer carbon chain structure. All right. I hope it is well understood. Please remove that concept or that idea in your head that organic chemistry is difficult. No, it isn't at all. Just pay attention, and if you do not understand it, go over it again and again, because repetition is the best way to understand any concept or to become perfect in any concept. So we continue again under carbon uniqueness. Again, too, is that carbon has the ability to form multiple bonds. I repeat, carbon has the ability to form multiple bonds. And the bonds can either be carbon-carbon single bond, carbon-carbon double bond, or carbon-carbon triple bond. Carbon-carbon single bond are mainly saturated compounds. Carbon-carbon double bond and carbon-carbon triple bond, these two are unsaturated. In our next episode, we'll then talk about deeply on saturated compounds or saturated hydrocarbon and unsaturated. Saturated in this episode 1 is single bond, carbon-carbon single bond. Carbon-carbon double bond and carbon-carbon triple bond are what? Unsaturated. Take note. Very, very simple. So when we go further, we'll then understand that carbon-carbon single bond are alkanes. We'll get there. Right? Carbon-carbon double bond are alkenes. Look at it. Alkene. Alkene. Simple. Carbon-carbon single bond. Alkane. See it now. A-N-E. Ane. Alkane. Alkene. Right? Carbon-carbon triple bond are called alkynes. Or alkyne. Is that clear now? You see, Y-N-E, ine, in, alkane, alkene, alkyne. All these are families of organic compounds. And when we get to this episode, we'll deep down into it. And you will now see that it is not difficult as they assume to be. No, it is not. I will move. Now, there is one important concept I would love to share with you. Is that carbon has the ability, or carbon can form a valency that is greater than 2, and that the maximum it can form is 4. I will explain that point if you don't get it twisted. Now, the truth is, we should understand that in the idea of carbon, carbon is an element, and that under bond theory or under Lewis structure, carbon can only carbon as an element must have what now? Must have bonds that is equal to 4. That is to say, 4 bonds is what surround the carbon atom. Let me explain. You and I know that the valency of carbon is above 2, and that carbon can form on its own, carbon can form 4, which is plus 2 and plus 4 are the oxidation state of carbon. In the case of CO, carbon 2, which is carbon 2 oxide. But in the case of CO2, carbon 4 oxide. But in the case of organic chemistry, we'll take it a little bit deeper. Now, carbon single bond, for example. Remember, please take note, this is where a lot of students are having so much issues with. For this carbon, as you can see, already have a single bond. This carbon 2 that you also see also already have a single bond. Now, carbon can form tetravalency. It means there must be 4 bonds of carbon. 4 bonds of carbon. Meaning, if carbon is already having 1, then we need extra 3 to make it tetravalent, which is how many this carbon we are having 1, 2, and 3. That's 4. So 1, 2, 3, 4. Why this carbon is already having 1? So if we have 1, 2, 3, 4. You see now that 1, 2, 3, 4. So and each of these bonds that are shooted out are filled with hydrogen. That is where the concept of hydrocarbon comes in. Please take note. On no account should a carbon contain more than 4 bonds. If not, you'll be breaking the rule. So, from having carbon, double bond, you are already aware that this carbon here has 2 bonds, this carbon here has 2 bonds, and this carbon here now, which is carbon A, let me label it like that. Carbon A here, we need extra 2 bonds to make it to be tetravalent. So you see it now, complete. Carbon here now has, this carbon here, B carbon has 2, so it also requires 2. So and so on and so forth. So let me take it a little bit further. I'm having carbon here, for example, and here is 2, and here is 1. This carbon here has 2. I will have to require 2. This carbon here now has 3. You may wonder how. Carbon here has 1, 2, and 1 here. Meaning, like label here A, here B, here C. This carbon here has, B carbon here has 3 bonds. 1, 2, 3. So it requires just 1, but that will shoot out. But this last carbon, which is carbon C here, has just 1. So it will also take what now? 3. So when they shoot out like this, you just know the concept. Another important carbon uniqueness is that carbon can combine with other elements easily. For example, carbon can combine with phosphorus, oxygen, nitrogen, sulfur, and the halogens, which include the fluorine, chlorine, bromine, and iodine. And in organic chemistry, all these are regarded as a substituent in some cases in the nomenclature, whereby each of them will end in a suffix of O, or they will be ending in O. Fluorine, fluoro, chlorine, chloro, bromine, bromo, iodine, iodo. So, fluoro, chloro, bromo, iodo. Is that clear now? So, this is basically an introduction to the field of organic chemistry. In our next episode, we'll talk about the classification of organic compounds, where we'll go deeper. Please, you've not subscribed to my YouTube channel, do well to subscribe, because more videos will be uploaded for you and you can also contact me with this, my telephone number 09081053321. For now, I remember humble self, adrenaline, the bazooka prophet. You are the best. God bless you.